The rational zero theorem. Now this looks awful. If you look at this, if f of x equals a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus dot, 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 a sub 1x and a sub 0, right? That all looks terrible. That just means if it's in descending order, then the coefficient of the biggest power is a sub n, the next biggest power is a sub n minus 1, all the way down to a sub 1 is the power of x, and then a sub 0 is the thing that doesn't have an x with it, okay? It has integer coefficients, p over q, where p over q is reduced to lowest terms and is a rational zero of f. Okay? Then p is a factor of the constant term, a sub 0, and q is a factor of the leading coefficient, a sub n. Note that a sub n and a sub 0 may be positive or negative, so we will use a plus or minus when finding these, and I will also use absolute value of a sub n and a sub 0 for that reason. I'm not going to worry about factoring it into positives and negatives and all that other business. I'm going to put a plus or minus in front of my possible rational zeros right here and take care of that scenario. So the factors of the constant term a sub 0, and really I'm going to use absolute value of this and absolute value of this, okay? That's what I'm going to use, and then take care of that absolute value business with my plus or minus. I'm going to disregard my signs and take care of it there. All right, so the rational zero theorem. This looks awful. It's a little easier to do than it is to actually look at and try to understand what all these words mean. If you look in your algebra book, you're going to see something just like what I just showed you, or very similar. But let's do 3 of these, and let's see what we can do. So use the rational zero theorem to list all possible rational zeros for each function. Note, do not attempt to find the zeros. I'm pretty sure that maybe all of these don't work, okay? So not with rationals. They may work with some irrationals or some complex numbers or something like that, but they don't work necessarily with what we find here in this list, all right? So the first thing we want to do, since I use plus or minus for my possible rational zeros, I will take the absolute value of a naught and the absolute value of a sub n, all right? I understand they might be negative, but I'm disregarding the sign for the purposes of finding the factors because of the plus or minus that I use, okay? So just understand that, all right? So 8 and 1. So then I need to factor each one of those things. So my factors of 8, right? List the factors for both a naught and a sub n. The factors of 8 are 1 and 8 and 2 and 4, right? What are the factors of 1? Well, the factors of 1 are just 1, all right? And then, so the factors are 1, 2, 4, and 8, right? I like to go down this side and back up this side to put them in order, all right? If you'll notice, anytime I factor, I do 1 in the number, then 2 if it works, then 3, then 4, and work my way up that way, all right? Then if I go down the left and back up the right, everything here is in order. I'm just OCD about putting them in order. It's not wrong if you do 1, 8, 2, and 4, or 1, 8, 4, 2, or whatever, okay? And the only factors of 1 are 1, so I just brought it down here, okay? So then what I want to do is I want to take my plus or minus and put all the factors here over 1, right? So I want to take all that and put it over 1. So let's look at what that looks like when I do that. So the possible rational zeros are plus or minus 1 over 1. That's this one over this one. That's this 2 over this one. 4 over 1. 8 over 1. Okay? And then the last thing I want to do is to simplify those. Okay? So here I want you to note, you only see 4 numbers right here, right? However, 1 and negative 1 are both answers. 2 and negative 2. 4 and negative 4, right? So you have how many possible rational zeros here? 8. You have 8 possible rational zeros. At most, you will find 3 answers. So 3 out of 8 is your chance of finding one. Okay? On the first try, so on and so forth. So, you know, it doesn't work good with 3 into 8, but anyway, it's preferable also to leave the answer as plus or minus 1, 2, 4, and 8 and not list all 8 of them out. So you can simply list it this way, and then I have the answer boxed here. Okay? I'm one of those teachers. I like my answers boxed. I also give you a box to put them in. All right, so let's look at the next one. What is my a sub 0 of the next one? There's my a sub 0, right? What is my a sub n? The 3. So let's see if that's what we have here. A sub 0, 8, a sub n, 3. And again, I'm not worried about whether they're plus or minus. I'm taking the absolute value because I'm going to worry about that later. My factors of 8 are 1, 2, 4, and 8, right? Again, I saw the same thing before. What are my factors of 3? 1 and 3. There are no other factors of 3. So then I'm going to take the factors. So I'm going to take 1 over 1, right? 2 over 1, 4 over 1, 8 over 1. Then I have to go back, though. After I do all the ones over 1, I've got to do 1 over 3, 2 over 3, 4 over 3, and 8 over 3. That's where I get these 4 from, okay? So every number here has to go over each one of these numbers. So let me just... So you're going to have, in this case, 4 times 2. You're going to have 8 things listed across here, okay? That doesn't mean you're going to end up with 8 things, because what do we have to do after we do what I just did? Simplify, right? Simplify. So any number over 1, all of these right here that are over 1 are just going to become the number, right? 1, 2, 4, and 8. Do any of these simplify? 1/3, 2/3, 4/3, or 8/3? No, none of those simplify. So actually we still keep 8 here. But when we look at it, we have 1, 2, 4, 8, and then 1/3, 2/3, 4/3, and 8/3. All right, I don't know if you saw the line come across here, down here, this part, but that means it's going to mess up, so I have to do this. So sorry for that on my video there. All right, so then the next one, f of x, 6x to the 5th, right, all this other stuff here. This is my a sub n, this is my a sub 0. But again, I don't care about the negative. I'm going to just take my... I'm just going to take my 24, right, absolute value of this, and my 6, the absolute value of 6. And then I need the factors of those things. So if I were to factor 24, I get 1, I get 1 and 24, I get 2 and 12, I get 3 and 8, and I get what? 4 and 6. And again, I like to go down this side and back up this side when I list them. So when you see it on the next page, it's going to go 1, 2, 3, 4, 6, 8, 12, 24. And then here, 1 and 6, and 2 and 3. And I go down and back up. So it's going to be 1, 2, 3, 6. Okay? So that's my factors I have listed here. 1, 2, 3, 4, 6, 8, 12, 24. 1, 2, 3, 6. Then I take every factor here and put it over every factor here. So I have 8 things here and 4 here, which means I'm going to have 32 fractions. Again, this problem is for the sake of showing you, right? So I took 1, 2, 3, 4, 6, 8, and 12. I took all of them and divided them by 1. I took all those numbers and divided them by 2. I took all of those numbers and divided them by 3, and all of them and divided them by 6. Right? 1 over 1, 2 over 1, 3 over 1, 1 over 2, 2 over 2, 3 over 2, all the way through. 1 over 3, 2 over 3, all the way to 24 over 3, and then 1 over 6, 2 over 6, 3 over 6, 4 over 6, all the way to 24 over 6. Did all those things. And then I come back and I have to simplify them. Again, all of these that are over 1, they're just going to become the whole numbers, right? 1/2 doesn't simplify. That becomes 1. 3 halves. 4 halves. Does that simplify to 2? That becomes 3. This becomes 4. This becomes 6. This becomes 12. So as I simplify them, guess what? Look, here I have 1, 2, 3, 4, 6, 8, 12, and 24, right? So I already have 1. I already have 2. I already have 3, right? I already have all these, 4, 6, and 12. And guess what? 1/3 doesn't simplify. 2/3 doesn't. 3/3 is 1. And guess what? I already have 1. 4/3, 6/3 is 2. I already have it. 8/3, 12/3 is 4. I already have it. 24/3 is 8. Anytime these divide out, guess what? And they simplify, you already have it. If you did it in this order, okay? But it's going to show up at some point. 1/6, that becomes 1/3. Guess what? I already have 1/3 right here, okay? 3/6 is 1/2. I already have a 1/2 over there somewhere, right here, okay? 4/6 is 2/3. Have it right here. 6 over 6 is 1. I already have it. This is going to be 4 over 3. I already had it right here. 12/6 is 2. Already have it, and that's 4. Already have it. So after I take all the ones I already have out, this is my list I end up with. Oh, I'm sorry. I simplified them all right here. I simplified them all right here like I just wrote down. So 1 we already have, 2, 3, 4, 6, 12 we already have, 1, 2, 4, and 8 we already have. We have all these now. So if we take those out that we already had, that's the list we end up with. 1, 2, 3, 4, 6, 8, 12, 24. Then we have 1/2, 3 halves are the only ones over 2 that didn't already have something. Then we have 4 of them over 3, 1/3, 2/3, 4/3, and 8/3 that didn't simplify to something else. And then only the 1/6 that didn't simplify to something else. So we have here, I think if we count them up, we have 15. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So really, not 15, but 15 times 2, we have 30 possible rational zeros for that problem. That's why I told you not to find it, okay? That was for the sake of exercise of finding that, not because I wanted to make you have to go find all the zeros. Notice all the minus 13s in the middle. That thing probably doesn't factor with any of those numbers. Well, I guess it's possible, but most likely it's going to be some radical or imaginary number or something, okay? So that is the possible rational zeros.